Hello, welcome back. So in the previous part, we have designed the lacing system. Now we will solve the last step, which is about the connections. We have to connect the lacing bar. So the connection may be in the form of bolted connection. It may be in the form of welded connection. So we will solve for both cases. So first, I will say that we have completed this part. We have designed the lacing system, except the connections. So now first we will design bolted connection. Now in bolted connection, what we actually do, we actually find out the number of bolts required to connect lacings. Now number of bolts required to connect the lacing bar, we can find out this by using this relation F upon the R. Now in this case, F is the force in lacing bar. So we have already calculated this force. It is approximately 17 point something. Now R is called the bolt value. Now bolt value, I hope you remember, bolt value is actually the least of shear strength of bolt and the bearing strength of bolt. So here, to find out the number of bolts, first we will find out the bolt value, because force in lacing bar we have already calculated, which is around 17, and we have to find out the bolt value. So to find out the value of bolt, we have to find out the strength of bolt in shear strength and in bearing strength. So the least value, bolt value is actually the least of, it is actually the least of shearing strength and bearing strength. So we will calculate the strength of bolt in shearing criteria and bearing criteria. So whichever gives us the least value will be the bolt value. As I said earlier, we will solve bolted connection by two criteria. One, when the lacing bar is not overlapped to each other, and the other condition is when lacing bar is overlapped to each other, because in both cases the case will be different. I will show you how. First case is if the lacing are not overlap each other. Well, I will show you. For example, this is the main component. The other component will be here. So when one lacing bar will be here, we will connect when one lacing bar like this. So one bolt will be here and the other bolt will be here. Similarly, the other lacing bar, the second lacing bar, will not be above on it. The other lacing bar will be like this. It may be like this. So this will be the bolt. So this is how this is the first case when both of these lacing bar are not on, I mean they are not overlapping on each other. In the second case, it will be like this, like here the same component. So in the second case, the case may be like this. One lacing bar is going like this and the another lacing bar will be above it like this. So in that case, this will be the bolt. So in that case, we are going to use this single bolt, but at the same time, if I cut the cross section, at the same place, it will look like this. First, the flange of this section, and then this lacing bar, and then this lacing bar. So it will look like this. First, this will be the thickness of this member. Then above it, this will be the lacing bar. So it will be above it. Then this one above it. And to connect them, we will make hole and we will use the bolt like this. So in that case, you can see there is one shear plane. This will be the one shear plane, and this one will be the second shear plane. So there are two shear plane. So that is why we say that it will be in double shear. While in this case, you can see if I cut the cross section along this section or along this section, then it will look like this. First, this will be the thickness. It will look like this. Then at this section, only one bar is there. So therefore, only two bars will have to be connected, and therefore only one section will be here. So it means in this case, the bolt will be in single shear. And in this case, it is in the double shear. So that is the main difference that will be done here. So that is the case. So now, sorry. So first, we will assume that, we have already assumed that we are using 16 mm dia bolt, and grade of bolt is 4.6 and connecting both the lacing bar. Also, one more thing that I have assumed, that the shear plane will not pass through the threaded portion. Well, I hope you already remember that a bolt is having this head, and this is the shank, and in some part of the shank there is no threads, only on the lower part it is having threads, and generally we assume that that shear plane will pass through this. But this time what I'm assuming, that shear plane will not pass through this, it will pass along the full shank dia. Okay, so what is the difference? I hope you remember that when we calculate the shear strength, the formula for this is An into Fu plus ASB into Fu upon under root 3 into gamma M1, something like this. This is the formula that we use. So this An generally we use in case when the threads, when the shear plane passes through the threads, and this ASB we use when the shear plane passes through this case. So this time what I am going to do is, I am assuming that all the shear plane will pass through this one, which means we are not going to take this this value this time. Only this value will be taken. So now strength of bolt in the single shear this time. As I said, in this case, as the lacing bar will not be overlapped to each other, so in this case it will be in the single shear, and for the single shear it will be ASB into Fu by root 3 upon gamma MB. So putting all the values, pi d square by 4. So ASB will be here pi d square by 4, and Fu value we already know, it will be 400 for this bolt. So the strength of the bolt in single shear is 37.147 kilonewton for shear criteria. Now we will find out the strength in bear. Now in the bearing strength, I hope you remember that a very important parameter is to be calculated, which is Kb, and Kb depends on many factors like the minimum pitch, edge distance. So first we will assume the minimum pitch. So minimum pitch as per IS code can be taken as 2.5 times of D. D is the dia of bar. So taking pitch as 40. Similarly, we will also assume the edge distance. So minimum edge distance is 1.5 times of dia of hole. So putting the value. So dia of hole, if we are using the 16 mm dia, then hole dia will be 18. So 1.5 times of 18 is 27. So let's assuming pitch as 50 mm and edge distance as 30 mm. So now we will be able to identify the Kb value. So Kb value will be the smaller of this one, this one, this one. I hope it is clear to all of you. If If the bolt connection is not clear to you, then please refer to my lectures, which is about of the bolted connection. So KB value can be calculated from all four values. So minimum value of KB will be taken here, which is 0.56. So now we will use this value to calculate the bearing strength of the bolt, and bearing strength formula to calculate the, bearing strength of the bolt can be calculated using this formula. So putting all the values here, yes, T value will be taking, we have to see which value is to be taken, because lacing bar thickness is 12, like I'm again showing you the cross section. Uh, in this case, for example, this is the part where we have to connect, sorry, where we have to connect the bolt. So in this case, thickness of this bar and thickness of this section, this is actually the channel section which we are connecting here. So channel section thickness and thickness of bar. So least one value will be taken as here. So from the steel table we can find out the channel section thickness. So here we are going to take the this thickness, which is the thickness of the bar, which is 12 mm. Similarly, we are taking all other value. Dia D is the dia of the shank. Putting all the values here, then we get the bearing strength as 88.167. So least value, bolt value will be the least one. So the strength of bolt will be this one, because shear strength of the bolt is less than the bearing strength. So this is the bolt value. Now we can find out the number of bolts. Number of bolts will be force in the lacing bar, which is 17.67, and the strength of bolt, which is the bolt value. So here number of bolts required will be 0.5. So we are rounding off this value to 1. So at each end we are going to provide one bolt to connect the lacing bar. So that is the connection design for the bolted connection in this case. Similarly, we will see the other case in the next part. Thank you.